Alrighty, howdy folks. Today let's look at chapter 2 section 3. This is about calculating limits using the limit laws. Okay. Right in previously we looked at graphs, and that's how we figured out the limits of things, right? But not always can you keep on drawing graphs and figure out the limit based on them. So there are some simpler techniques, and to be able to use those techniques, we need to understand certain limit laws, and that's what this is all about. Suppose that C is a constant. Suppose that C is a constant with the limits. With the limit of f of x as x approaches a, and limit of what? And the limits. Come on. Suppose that C is a constant and the limit of f of x as x approaches a and limit of g of x as x approaches a exist. Then certain things are going to be automatically true. For instance, limit of a sum is equal to sum of the limits. What? Now notice, does that make sense? Here we are supposed to figure out the limit as x approaches a of what? F of x, some function f, plus g of x, or you could have f of x minus g of x. Let's focus on the plus part. If you needed to figure out the limit of this sum, f of x plus g of x, what this law says is you can figure out the limit individually, just the limit of f of x as x approaches a and limit of g of x as x approaches a, and add them. So that's what mathematicians express as limit of a sum is equal to sum of the limits. Similarly, limit of a difference, f of x minus g of x, is the limit of the difference. Limit of a difference is equal to difference of the limits. Let me put it that way. That's the idea. Like if you feel like, oh, come on, duh, that seems obvious, you're right. It's a simple thing. And the second one is limit of a constant multiple. What? Constant multiple of a function. Meaning f is a function and you're multiplying it by a constant, and you need to figure out the limit of that constant multiple. Then what this says is you can yank that constant outside and then multiply the limit of f of x as x approaches a. If that is intuitively obvious, I agree. The reason I need to go through all of these is sometimes it doesn't work like that. Especially pretty soon we are going to get into derivatives. There, certain things won't be obvious. Okay, so do focus and pay attention to this. 3. Limit of a product is equal to product of the limits. Cool? I don't need to explain that, I take it. Limit of a quotient is equal to quotient of the limits. Limit of f of x over g of x is, you can take the limit separately and divide them, and that's perfectly fine. Of course, provided the limit of g of x as x approaches a is not equal to 0. Okay? What is this? Limit of the quantity f of x raised to n as x approaches a. Here, you can take just the limit of f of x, and whatever result you get, you can raise that to a power of n. And n what? What's this funny looking thing? Well, that is just a element of, where n is an element of. Okay, what's with this funny z? That is Zahlen, Z-H-A-L-E-N. It's a German word for integer. So all I'm saying in this fancy way is n is a positive integer. What do I mean by positive integer? positive integers are 1, 2, 3, 4, 5, 6, so on. Cool. So n is a positive integer. And limit of c, where c is a constant here, as x approaches a is just c. This is stated as limit of a constant is equal to the constant. Okay. All right. Limit of x as x approaches a is equal to a. Here, the idea is it almost works as if you are plugging in a for x. Okay, you are plugging a for x. But if you recall, that's blasphemy, man. How could you do that? When you talked about limits, you clearly said we will always let x approach a, but make sure x is not equal to a, right? But now I seem to be violating that same thing that I wagged my finger and warned you about. How could I do that? Well, it turns out in some cases that is okay. The result that you get for what happens when x merely approaches a is exactly the same as what happens when x is equal to a in some cases. And in those cases, you can just simply plug in x equal to a. Cool? That's the idea. And so when you think of it that way, everything makes perfect sense. And here, take a look at this one. Limit of x to the n as x approaches a. Once again, you can think of it as, hey, let me plug x equals a. And what do you get if you plug x equals a? You get a to the n. That's the answer. How could, same answer, okay? Same reason you can plug in. Where n is a positive integer. 1, 2, 3, 4, 5, 6, so on. Cool. Limit as x approaches a of nth root of x. Once again, you can plug in a for x and you get nth root of a. That's the answer. Of course, provided n is a positive integer. And, whoa, what's with this? A is greater than 0 if n is even. A is greater than 0 if n is even. Any idea why that is? Can you think of an example? Apparently, a must be greater than 0 if n is even. Can you pick an even number? 2 is an even number. So we have 2th root of x, that is square root of x. In the event we have an even root like square root, could a be negative? No, square root of a negative number is imaginary, is complex, right? So we want to stay, at least in this course, unless stated otherwise, we want to stay with real numbers. That is the warning. That is the reason why if you're taking the square root or the 4th root or the 6th root, some even root, you better make sure that a is a positive number, must be greater than 0. Okay, so if n is odd, it's okay. How come a could be anything, positive or negative, if n is odd? Does that make sense? Okay, let's see. Pick 3 for n. So that in that case, we're talking about cube root of x. Could x be, say, -8? A negative number? What is cube root of -8? Is that real number? Yeah, of course, cube root of -8 is -2. But square root of -8 is complex, right? That's why you have to avoid square root. Even roots, but odd roots are okay. If a is negative, odd roots are okay. That's the idea. Cool. Let's move on. Limit of nth root of f of x as x approaches a, you can take the limit of f of x as x approaches a, and whatever result you get, you can take the nth root of that. That's perfectly fine. All of these things actually have to be proved, but you are at a level where you don't have to worry too much about the proofs and all that. You just take my word for it and quite possibly sort of memorize this. You must remember all of these things, folks. Okay? Where n is a positive integer. Cool. Those are the limit laws. All right. Next. Direct substitution property. If f is a polynomial or a rational function and a is in the domain of f, then limit of f of x as x approaches a equals f of a. This is what I was talking about. Earlier I said, when we say limit as x approaches a, x merely approaches, x will never equal a, right? Finger wagging. In some cases, like if f is a polynomial or a rational function, you got to be careful. A must be in the domain. The idea there being, if you have a rational function and when you plug in a, the denominator goes to 0. Well, that could not be, that the function is undefined at that a, and so that could not be in the domain. That a value cannot be in the domain of the function f. Did that make sense? If you have a rational function where when you plug in a, the denominator goes to 0, such an a cannot be in the domain. But if you don't have any issues like that, yeah, limit of f of x as x approaches a is simply equal to f of a. That's the point here. Cool? All right. Theorem. Whoa. Limit of f of x as x approaches a equals L. What's with the double arrow? Hey, remember from that logic thing? That is if and only if. Limit of f of x as x approaches a equals L, if and only if limit of f of x as x approaches a minus equals L, and that should be equal to limit of f of x as x approaches a plus. This is something we already discussed in the previous section, right? I said for a limit to exist, both the left and the right limit must be equal. And when they do, then the limit, what the left limit or the right limit is, that's the limit of the function. That's it. Squeeze theorem. This is a very interesting theorem. You don't run into this a whole lot at lower levels, but when you, I think here there are some problems with the squeeze theorem, but when you go to slightly higher level classes and at a graduate level especially, boy, a whole bunch of theorems you will have to invoke squeeze theorem, right? If you want to prove some things, you have to use this. So let's see what in the world this is talking about. Let's say we have f of x being less than or equal to g of x is less than or equal to h of x when x is near a, except possibly at a, right? So far away from a, what exactly is the behavior of f, g, and h? Yeah, we are not worried about it. What we are focusing on is right around a, meaning in the neighborhood of a, right? In the sense, you go to a, go to the right a little bit, go to the left a little bit, right? You can see an interval that encompasses this a. In that small interval, if this is true, then we can apply the limit, we can apply the squeeze theorem. And the thing says, if limit of f of x as x approaches a is equal to limit of h of x as x approaches a, and that those two limits are equal to L, what? This outer function f of x, that one has a limit of L, and this rightmost function h of x, that also has a limit of L as x approaches a. Then all this is saying is the one that is squeezed in between these two, that limit will also be equal to L. Now you're like, what? Yeah, it is useful because sometimes it just so happens it's easy to find the limit of f of x and limit of h of x. But as such, what exactly is limit of g of x? You may not be able to figure that out that easily. But the moment you use this squeeze theorem, because you can find these limits of these outer functions much more readily, you can figure out what the limit of the middle one is that is squeezed in between. That's the idea. Cool? All right. With that, problem. Evaluate the limit and justify each step by indicating the appropriate limit laws. What's limit as x approaches 3 of 2x square minus 3x plus 1? Right? I'm not asking you to draw a figure or anything like that. Apply the limit laws and figure this limit out. Well, would you agree that can we apply one of those limit laws that says limit of a sum or difference is equal to sum of the limits or difference of the limits? Do we have these three functions adding up, adding, subtracting like that? Could we just take the limit of each one of them and add, subtract as the case may be? Yep, we can do that. So we can say this. Cool. And what is this? This is the limit law 1. Makes sense? Cool. Next. Isn't that equal to 2 times limit of x squared as x approaches 3? Whoa, where'd you get that from, man? That's because a constant multiple rule. Limit of a constant 2 times x squared, I can pull this constant multiple outside of the limit and say 2 times limit of x squared as x approaches 3. Similarly, I can pull this constant multiple 3 outside of the limit and say 3 times limit of x and limit of 1 as x approaches 3. Now, there is a limit law. This is, by the way, limit law 2, constant multiple thing. And there is a limit law. How do we go with the next step? There's a limit law that says limit of x to the n, when n is a positive integer, is a to the n. So by applying that, we can just, or rather simply plug 3 and you're good. 3 square 2 times 3 square minus 3 times plug 3 for x, and you get 3 times 3, and limit of a constant is that constant itself. It's 1. Right? I'm thinking this is fairly straightforward. Laws 8, 7, and 6. So we applied 8 here, 7 here, and 6 here. And if you simplify that, you get 10. Now, ladies and gentlemen, take a look at how I solved the problem. Notice I said the problem statement and then the solution, and in the next line I started with this and put equal signs. I said this is equal to this, and next I went equal to that, equal to this, equal to this. You must learn to write mathematics correctly. So don't be sloppy and forget to put equal signs. Just write down, hey, I got the same answer as you, man. No. You must learn to write mathematics clearly. Okay? And also, when you work these problems out, don't do chicken scratch. Right? Be very careful how you write it. You're all going to be engineers or other kinds of professionals. So your work should look like that. And if you If you get a chance, try to see some, some professional people, how they do, or even just look at what I did, right? This is how it should look. I know I have used a PowerPoint to do this, but even when I write with my own hand, and I'm not pressed for time, it looks like this. So always make sure that you write clearly, put equal signs where equal signs belong, and put imply signs where imply signs belong. And also, it's always a good idea to box the final answer, because that way I would know, okay, this is the answer the student wants to claim. Cool? All right, next. Another problem. Evaluate the limit if it exists. Limit of x square minus 2x over x square plus 2x minus 8. Is that a rational function? Do we have a polynomial over polynomial? Yep, we do. Did I earlier say that if you have a polynomial or a rational function, you can do the direct substitution method? That means just go ahead and plug 2. Let's see what happens. What happens if we do that is 2 square is 4. 4 minus 2 times 2 is 4. 4 minus 4 is 0. Uh-oh, the top is 0. 4 plus 4 is 8. 8 minus 8 is 0. Whoa. We get 0 over 0. What is 0 over 0? Undefined. 0 over 0 is undefined. So, should we say the limit does not exist? You follow what I'm saying? When we plug x equals 2, we get 0 over 0. The answer is no, you don't say the limit does not exist. There's something you need to do. What I have done is I have shown you here the graph of this x square minus 2x over x square plus 2x minus 8. And I'll discuss the graph in just a second. I just put it there and I'll come back to it in a second. So solution, as a first step in evaluating the limit, let us plug x equals 2. This is what I was talking about. When we do, we get 0 over 0, which is undefined. Right? All right. So as a second step, let us see if we can simplify the expression. That's the idea. Can we simplify what we got there? Can you factor x square minus 2x? Yep. You can write that as x times x minus 2. Can you factor x square plus 2x minus 8? Yep. Ooh. I said, yeah. Do you know how to factor x squared plus 2x minus 8? This is something that you learned in pre-calculus or algebra 2, right? It's a quadratic. You factor this as x plus 4 times x minus 2, right? Also notice equal sign. This one equals that equals whatever I get. After doing this, can we simplify? Can we say cross this x minus 2 out, divide this x minus 2 and this x minus 2, that just becomes over 1, right? But x minus 2 over x minus 2 is 1. Can we do that? Can we cancel x minus 2 and x minus 2 like that? Always? Do you know what I'm asking? Let me see if I can write with this pen. Good. If I have AB over AC, can I cancel A and A? Yeah, man, that's B over C. What if A were to be 0? Then I cannot. right? So be very careful when you say, yep, you can cancel the same, if it's the same term and multiplying, you can cancel. No, not if it is equal to 0. So should we be worried about that? Could x minus 2 be equal to 0? Yeah, in a way, yeah. But notice, here we are saying x approaches 2. When we are talking about limit, once again we are saying x will merely approach 2 but not equal to. Well, if we are promising that x will not equal 2, then we are okay by saying that we can confidently say that x minus 2 won't be 0. So we don't have any problem of cancelling these. And so we say limit of x over x plus 4. Okay. So that expression x square minus 2x over x squared, this could be simplified to x over x plus 4. Now, ladies and gentlemen, the graph that you see here is of x square minus 2x over x square plus 2x minus 8. And that one has a hole at x equals 2. How does the graph of x over x plus 4 look like? Let me repeat that. Pay attention to that question, please. The graph of the original one looks like this, and it has a hole in it at x equals 2. How does the graph of x over x plus 4 look like? It's the same graph, but there won't be any hole. Exact same everywhere else. Except where that hole is, it just continues that same trend. That's the difference between the two. However, notice the very first time I talked about limits, I showed you this. If you compute the limit as, if you let x approach 2 from the right, the f of x values will approach whatever this value is. If this hole were not to be there, or if that hole were to be plugged in, would be filled up, let us say. If that hole were to be filled up, whatever the y value would approach, whatever the y value is, that's what x would approach. Jeez, come on, Sammy, wake up. If we were to fill the hole up, whatever the y value is, that is precisely the y value that, as x approaches 2 from the right, would have. The y values would approach that value. So that's why we can simplify and then plug in the value of x equals 2. So if you plug in, you get 2 over 2 plus 4, and that's equal to 2/6 or 1/3. Right? So the limit of this is 1/3. Isn't that fascinating? Even though originally when we plugged in x equals 2, we got 0 over 0, which is undefined, which is what this hole indicates. At x equals 2, this original graph is undefined. Original function is undefined, but the simplified version is defined there, and so far as the limit as x approaches 2 is concerned, that's okay. Whatever we get is the limit of the original function. Please allow this concept to sink in quite a bit. And there will be some homework problems based on this. Please be sure to work them. And I'm going to show you quite a few more examples, okay? All right, move on. Evaluate x square minus 2x over x square plus 2x minus 8. The same thing, but we're talking about limit as x approaches -4. Okay, let's see. -4, plug in as a first step. -4 times the quantity square is positive 16 minus 2 times -4 minus -8, or 16 plus 8 is 24, and the denominator goes to 0. Okay, 16 minus 8 minus 8, so that the denominator goes to 0. So we have 24 over 0. Okay. And that is definitely undefined. Okay. But let's see if we can simplify this expression. I'm sure we can, because that's what we saw last time, right? The previous problem was exactly the same one, except the limit we computed is different. And so we have limit of x over x plus 4. Whoa, what is this limit now? Well, you get negative 4 over 0 if you plug in negative 4 for x, which is undefined. But do you remember what we did in the previous section? Whenever you bump into something like this, we have a non-zero term on the top over a 0, then we have an infinity involved. Is it positive infinity or negative infinity? That's something that we need to check. So I'm saying, applying the techniques we learned in the previous section, we observe that as x approaches negative 4 from the left, this would go to positive infinity. How'd you get that, man? I got that by saying negative 4 from the left. So pick a number to the left of negative 4. What would be to the left of negative 4? Negative 4.01. Right? Negative 4.01 will be to the left of negative 4. Negative 4, negative 5, negative 6, though they are all to the left of negative 4. I wish I had a real number line drawn here just to indicate that. But otherwise, please draw for yourself and verify that what I'm saying is true. Okay, negative 4.01. The top x would be negative 4.01 divided by negative 4.01 plus 4 is negative 0.01. Okay, it's negative 0.01. So you get a negative 4 over negative 4.01 divided by negative 0.01 is positive 401. Right? You can plug numbers and see for yourself, folks. So that's a positive 401. If you come even closer, negative 4.001, you will get 4001 and 40,001 and so on. So that's definitely approaching positive infinity. Whereas if you look at the right-hand limit, then you get negative infinity by a similar argument. Pick x to be negative 3.9, which is slightly to the right of this. And then you will have a negative 3.9 over 0.01, positive 0.01, and that's going to be a negative number. And so that goes to negative infinity. The question is not about left-hand limit or right-hand limit, but the limit itself. However, noticing that the left limit is not equal to right limit, would you agree? The left-hand limit is not equal to the right-hand limit. So what can we conclude about the limit itself? Limit does not exist. Limit as x approaches negative 4 does not exist. Cool? All right. Whoa. Let's see. This is a very nice problem. As a first step, let's plug x equals 2. So we get 4 times 2 is 8, 8 plus 1 is 9, square root of 9 is positive 3, 3 minus 3 is 0, and 2 minus 2 is also 0. Oh, we have a 0 over 0. That's undefined, man, so limit don't exist. No, don't do that. Do not do that. When you have 0 over 0, you should see if you can simplify this in some way. Simplify this? How do you simplify that? Right? Check this out. Can we simplify by rationalizing the numerator. Right? We have something of the form square root of 4x plus 1 minus 3. How do we rationalize that? Well, multiply by its conjugate, square root of 4x plus 1 plus 3. Well, if you're multiplying by something on the top, you better multiply the bottom also by the exact same thing, right? And that's what we will do. Cool? And multiplied by the conjugate of the numerator. Okay, what does it do? Does the top remind you of something? Square root of 4x plus 1 minus 3 times square root of 4x plus 1 plus 3. Does that look like a minus b times a plus b? What is a minus b times a plus b? Hey, that's difference of squares. Yep. So, could we use the difference of squares and say, this product is nothing but the square of this square root, which means the square root goes away, and the square of the 3 minus the square of the 3, which is 4x plus 1 minus 9 at the top, over x minus 2 term. Okay, I don't know, man. That don't look any simple at all. Let's see. If you simplify the top, 4x plus 1 minus 9, does that become 4x minus 8? Okay, now 4x minus 8, can you factor a 4 out of that and write that as 4 times x minus 2? Yes. Now do the x minus 2 and x minus 2 cancel? Because we are taking limit as x approaches to, yep. So that simplifies to this. Now can you plug in 2 and see what happens? So 4 on the top, 4 times 2 is 8. 8 plus 1 is 9. Square root of 9 is 3. 3 plus 3 is 6. You get 4 over 6. Ta-da! That's equal to 2/3. Right? Now check that out. So this is a very nice problem. I didn't do this, but typically I put 3 stars on problems like this. What that means is that problem or a problem just like that is almost a guarantee to show up in a quiz or test. Okay, so be absolutely sure to see how this problem has been worked out and be sure to work on similar problems in the book. Okay, all right. Evaluate to the limit. Ooh, this is another very important problem. Again, as a first step, what do we do? Did you say plug h equal to 0? Yeah, wonderful. If you did that, man. I was going to say something funny, but that's not funny. I was going to say go grab a beer or something like that, but you guys are kids, so I shouldn't say stuff like that. I'm sorry. So let's plug in h equal to 0. So what happens? 3 plus 0 is 3. 3 to the negative 1 is 1/3. Minus 3 to the negative 1, 1/3. 1/3 minus 1/3 is 0. Over 0. Oh, 0 over 0. That's undefined, man. So this only means we need to somehow simplify this. How do we simplify something like this? Right? Check this out. What exactly is 3 plus h, the quantity raised to negative 1 mean? Would you agree that it's the same as 1 over 3 plus h? Similarly, 3 to the negative 1 is 1 over 3. So let's write that way. And then let's subtract these two fractions. And so how do you do that? the common denominator is 3 times 3 plus h. Common denominator over the first denominator, which is 3. 3 times 1 is 3. That's what I wrote here. What? This is what I do. I figure out the common denominator and I do the common denominator over the first denominator, which gives me 3. And I take that quotient and multiply by the top, which is 1. 3 times 1. That's what I wrote. And because there is a subtraction going on, I put the minus sign here. Now I do the same thing as what I did for the first fraction, that is common denominator over the second denominator, which is 3. So 3 times 3 plus h over 3, that gives me 3 plus h. That quotient I multiply by this numerator, which is 1. So that's what you see. 3 plus h times 1 is 3 plus h. That's how I add and subtract fractions. Okay? All right. Now what happens? Well, when you expand this, would you agree this is 3 minus h? Be sure to distribute the negative to both of them, folks. 3 minus h. But 3 minus 3 is 0. So 0 minus h is negative h over. Now, a over b. Think of this h over. No, how about this? Yeah. We have a top fraction divided by h. Dividing by h is the same as multiplying by 1 over h. It's reciprocal, right? So take the top fraction and multiply by 1 over h. When you do that, this is what you get, right? Now can we cancel the h's? Yep, because h is approaching 0 and h is not equal to 0. Okay, and then what? We get this. Now plug h equal to 0 and you get negative 1/9. Isn't that fascinating? What was 0 over 0 as a limit, in fact, turns out to be negative 1/9. You need this particular one. I don't know if you recently took pre-calculus algebra, you would have seen something called difference quotient, and they had you simplify expressions of this kind going through what I did here. They did that in pre-calculus because they knew you would be needing that here in calculus 1. Okay? All right. Absolute value. Please pay attention to this stuff. One thing is, all American kids, I know this for sure. I mean, every high school student knows what is absolute value of 2. Everybody will jump up and say 2. What is absolute value of negative 2? That's also 2. And now, they also know the reason why that is the case. Boys and girls, why is absolute value of negative 2 equal to positive 2? And they say, that is because absolute value is nothing but the distance from 0 on the number line. And since distance cannot be negative, the distance from 0 to negative 2 is just 2, and that's why absolute value of negative 2 is 2. Right? That's what kids would say. There's nothing wrong with that. That's good. But unfortunately, it is inadequate. At this level, that kind of an understanding will not suffice. Why, man? Check this out. If I ask them this question, the same high school students. Alright, boys and girls, if x is less than or equal to 2, tell me, what would absolute value of x minus 5 equal? What? What number line? There is no number line that you can figure this out from, right? So that's why, what is the right way? What is the college way of figuring out absolute values? That is going by the definition of absolute value. Okay. Notice, mathematicians do not define absolute value as the distance from zero on a number line. That's not the way they define. Instead, does anybody know how to define absolute value? Absolute value of x is equal to x if x is greater than or equal to 0, negative x if x is less than 0. That's the way to define using this piecewise definition. Okay, what's the big deal about this, man? Oh, there's a big deal about this. This is real big deal. To help you understand this definition, let me reread this again, but I'm going to do something. Wherever I see an x, I will say quantity. Okay? So, absolute value of a quantity equals the quantity if the quantity is greater than or equal to 0, is negative of the quantity if the quantity is less than 0. Right? I can read like that. What's the big deal about that? The big deal about it is, now let's go back and ask this question. What is the absolute value of 2? I know you already know the answer to be 2. So what, that stupid man? No. I want you to use this definition and tell me, maybe more like, why is absolute value of 2 equals 2 based on this definition? Now you see. Okay, I said absolute value of a quantity. For x, I said quantity. So when we are looking at absolute value of 2, what is that quantity? The quantity is 2. Oh, okay, cool. So absolute value of a quantity 2, what should it equal? Well, it depends on whether the quantity is greater than or equal to 0 or less than 0, right? So this quantity 2, is it greater than or equal to 0? Yep, it is. So what should the absolute value of the quantity be equal to? The quantity itself. That means it must equal to itself. Whoa. Yeah. But come on. You're just making a mountain out of a molehill. No, I'm not. Okay? Now, you will see that to be even better when you apply it to absolute value of negative 2. Okay, what is the quantity now if you are looking at absolute value of negative 2? Negative 2. Is the quantity greater than or equal to 0 or less than 0? Less than 0. So what should the absolute value of that negative 2 be equal to? Negative of the quantity. That is negative of negative 2. Right? That is positive 2. That is the reason. Right? Is that what you guys do? You do a mic drop. Yeah. Okay, we went through all this. This is fine and dandy. Will it help us answer this question now? If x is less than or equal to 2, then absolute value of x minus 5 equals what? You betcha. What does an absolute value of a quantity depend on? Let me ask that again. Pay attention. What does an absolute value of a quantity depend on? It depends on whether the quantity is positive or negative. Right? In the event the quantity is positive, absolute value is the quantity itself. In the event the quantity is negative, it is negative. Absolute value of the quantity is negative of the quantity. So here, let's ask, in this context, can we say whether x minus 5, this quantity x minus 5, is greater than or equal to 0 or less than 0? What is it? What is the context? Oh, the context is x is less than or equal to 2. So x is taking on a value of 2, 1, 0, and of course fractions in between, -1, -2, and so on. Okay, when x takes on those values, what kind of values would x minus 5 take? For instance, let's say x is 2. 2 minus 5 is -3. Oh, that's a negative number. When x is 1, this is again negative. 0, negative. Any fraction in between, negative. So we clearly know that x minus 5 is actually negative if x is less than or equal to 2. And absolute value of a negative quantity, therefore, should be negative of the quantity. That is, this should be negative of x minus 5 is equal to 5 minus 6. What? Yes. Yes, it is. Right? Try to grasp this concept clearly and explain it to some of your friends, and you will blow their minds. Dude, you're really so smart, man. Or if you are a girl, you're really smart, girl. Yep. Okay. If x is greater than or equal to 5, then what do you think absolute value of x minus 5 would be? Simple. Ask yourself, will the quantity x minus 5 will it be positive or negative? Clearly, when x is greater than or equal to 5, x minus 5 is positive. So absolute value of the quantity is the quantity itself. So x minus 5 itself. Cool. All right. If x is greater than or equal to 3, then absolute value of 3 minus x. Greater than or equal to 3, plug some value, 4, right? 3 minus 4, oops, that -1. 3 minus 5, -2. Oh, okay. So 3 minus x is clearly negative. So absolute value of the quantity must be negative of the quantity, which means negative of 3 minus x or x minus 3. Cool, folks? All right. And the graph of absolute value of x looks like this, right? All right, and the graph of absolute value becomes very important pretty soon. Now, what is limit of absolute value of x as x approaches 0? When you know the graph, when you see the graph, it's fairly straightforward to figure out, right? As x is approaching 0 from the right, the y values are approaching 0. As x approaches 0 from the left, the y values are approaching 0. So, clearly 0. No issues whatsoever. Limit of absolute value of x as x approaches 0 is 0. With that, let's look at this one. Limit of x over absolute value of x as x approaches 0. Right? Very, very important problem, folks. Check this out. Since the absolute value of x is equal to x when x is, that's the definition. What can we say about x over absolute value of x? Any idea? We are supposed to look at x over absolute value of x, but we just said, okay, recall the definition of absolute value of x to be x if x is greater than or equal to 0, negative x if x is less than 0. I don't know what to do, man. Well, check this out. Let us split this into two conditions. If x were to be greater than or equal to 0, right? What can I replace absolute value of x with? Pay attention. Let us say x is greater than or equal to 0. What can I replace absolute value of x with? With an x. So, in that case, what would happen to this expression? X over x which is positive 1. Right? When is that true? Only when x is greater than or equal to 0. Cool. When x is less than 0, what should I replace absolute value of x with? With a negative x. So what do we have? X over negative x. And what is that equal to? Negative 1. That's how you figure this out. In the event x is greater than 0, replace absolute value of x with a positive x, giving you x over x to be 1. And in the event x is less than 0, x over negative x, replace absolute value of x with a negative x and you get negative 1. Is something conspicuous by its absence? Is that how you put it? Conspicuous by its absence. What about x equal to 0, man? Let's do that. If x takes on a value of 0, we have on the top 0 and in the bottom absolute value of 0. What in the world is absolute value of 0? Absolute value of 0 is 0. So we have 0 over 0, undefined. So x over absolute value of x is undefined when x is equal to 0. However, when x is greater than 0, we saw that it is equal to 1, and when x is less than 0, it's equal to negative 1. Right? Isn't that fascinating? So, if we were to draw a graph of it, it looks like this. At 0 itself, undefined. Okay. Now, what is the left-hand limit? The left-hand limit as x approaches 0 minus is negative 1. Right-hand limit, positive 1. So what is the limit as x approaches 0 itself? Does not exist because the left is not equal to right. Left limit is not equal to the right limit. Cool? Very important, very nice problem. All right. 3x limit as x approaches 5 minus of 3x minus 15 over absolute value of x minus 5. So, there's somebody at the door. All right, sorry about that. So where are we? Yeah. Solution. What do we do? Okay, 5 minus. Well, the question is, everything seems to hinge on what can we replace absolute value of x minus 5 with in this context? That is the key. What can we replace absolute value of x minus 5 with when x approaches 5 from the left? 5 from the left. So can you think of a number that is slightly to the left of 5? 4.9. Okay, 4.9 minus 5 is negative 0.1. Or another number, 4. 4 minus 5, negative 1. So definitely when x approaches 5 from the left, x minus 5 will be negative, right? Okay, and so that's what we will do. We will replace absolute value of x minus 5 with negative of x minus 5 because in this context, x minus 5 is a negative number and absolute value of a negative quantity is the negative of the quantity. And so you get x minus 5, x minus cancels and 3 over negative 1 or negative 3. I know the problem looks very simple and all that. I think I have one more problem, but please pay attention to what I'm about to say. If you were to replace absolute value of x minus 5 with a simple x minus 5. I don't care, man, like stupid absolute value. I'm going to remove that. And if you work this problem out, what will you get as the answer? Positive 3. Right? Then what is the difference? The difference is that a sign. You're supposed to get negative 3, but you got positive 3 by making that mistake. Oh, that's a simple mistake. No, it's not a simple mistake. It is an egregious blunder. You did not understand the concept of absolute value at all, and you did not apply it at all when you got that answer. You simply replaced willy-nilly with the absolute value of x minus 5 with the x minus 5. You should not do that. Right? So while I'm okay with you giving, making a sign error here and there, if you say 3 minus 4 is positive 1, I can live with it. But in this context, if you make a sign error, that's because you didn't apply a very important concept properly. I'll give 0 credit. Are you with me? All right. 3 minus absolute value of x over 3 plus x. Okay. Well, when x is approaching negative 3, either slightly from the right or slightly from the left, regardless, x is a negative value. So absolute value of x should be replaced by negative x. Does that make sense? Let me repeat that. We are talking about x approaching negative 3. Negative 3, when approached either from the right, slightly to the right, or from slightly to the left, is taking on negative values. For example, if you are approaching from the right, then negative 2.8, negative 2.9, negative 2.99, negative 2.999, like that. So it's taking on values like that. Whereas if x is approaching from the left of negative 3, it's taking on values of negative 3.5, negative 3.1, negative 3.01, and so on. Regardless, x is taking on negative values. So that means absolute value of x can be replaced or should be replaced by a negative x, which causes this to be, finally, I do have interval. So we are talking about negative 3 being here, and there is an interval just in the immediate neighborhood. X is actually negative. Of course, if you went farther away, you got positive 1, 2, 3, and so on. But that's not, we are talking about x approaching negative 3. So there is this interval surrounding it where x is actually negative. So we can replace absolute value of x with a negative x in this case. Okay? And so this simply becomes 3 plus x over 3 plus x, which is 1. Right? What a fascinating problem. If you, on the other hand, simply said 3 minus x over 3 plus x, you didn't say absolute value of x is negative x in this case and simply said 3 minus x, then you would get a completely different answer. You get some kind of an infinity kind of a stuff. But instead the answer is 1. All right, folks? Very, very important problem. Okay.